that we're going to discuss is the electrode classification group for shielded metal arc welding. But the first thing I want to talk to you about is the organization that established the rules for classifying electrodes. They are the American Welding Society, acronym AWS. If you're going to be a welder, you're going to stay in this field, you need to know who these guys are. They are like the gods of welding. They govern everything that we do in welding, from the materials that we use, to the testing protocols, to the electrodes that we are to use. So I'm going to go over the electrode classification groups, but first let me show you what electrodes are. I have some here on the table. There are hundreds of different types, but I have an E7018, I have an E6010 5P, I have an E7024, I have another E6010, and I have an E6011. Again, these are just some of the electrodes that we have in the classification groups. So the first thing I want to do is break down what those numbers and the letter E stand for. And I'm going to start with the E7018. Now the E stands for electrode. Although you don't see the letter E on the electrodes themselves, you will see the E on documentation, on paperwork. So you need to know what it stands for. The next numbers go together. The 7 and the 0 tell us the tensile strength, meaning how strong the rod is. We measure in thousands of pounds per square inch, so 70 represents 70,000 PSI. That means per square inch of weld that we make, it should sustain about that amount of pounds of pressure before cracking or breaking, if welded under the correct parameters, meaning was the rod in the oven where it's supposed to be? How long did you have it out? Did you weld a slightly convex, concave type of weld? So all those parameters play into play here. The next number represents the position that you can weld in. Now I'm going to have to go into a bit more detail on this. There are 4 basic positions: flat, horizontal, vertical, and overhead. So those are our positions in order. Now, when there is a 1 in the position spot, it means that I can do all of these positions. So that rod is an all position rod. The number may change. Now my position changes. If there is a 2 in the position spot, now I am limited to flat and horizontal fillet welds. In this position, I can only do fillets. And you must explain that fillets will be the type of welding that you're going to do with a rod that has a 2 in the position spot. The number may change again. Now my position changes. If there is a 3 in the position spot, I can now only weld in flat position. That is it. Do not get creative with these rods. You must weld as they have been designated to weld, or you're going to have some problems later on. The number might change again. Now we have a 4 in the position spot. Now my position changes. If there's a 4 in the position spot, I can weld in all the same positions as in 1, except now the vertical that I have here starts top down. In structural welds, in the all position rod, we start from the bottom and go up for vertical. But if there's a 4 in the position spot with this electrode, that vertical position will start at the top and come down. So that is what designations are for, to tell you what you can and cannot do with these electrodes. That's why it's very important to know how to read them. We have different numbers, as you saw from the beginning. That last number, in its entirety, represents the chemical composition, meaning the entire makeup of the rod, the material makeup, the flux content, and so forth. So it breaks down into 4 key aspects. So in its entirety is the chemical composition, which breaks down into C, P, P, F. The C represents current. This P represents penetration. This P represents polarity. And this F represents your flux content. All electrodes break down the same way. There just may be a difference in the tensile strength, a difference in the position to be used, a difference in the amount of current, difference in how much penetration you're going to actually achieve, a difference in the polarity, your AC/DC, and your flux content, meaning what the flux is made out of, which is the coating on the electrode. So this is what American Welding Society has established for us in how to read our electrodes and to determine how we are to use them on what material.